Because now I work with you guys second, so I do a better job teaching you guys. Actually, I think I do, but anyway. So let's think about it, right? Yeah, they like to complain. That's right. We know this is true, right? Well, actually, let me do a few more terms. Okay, you'd agree with that so far, right? Okay. Now, what if I did this? What am I doing now in blue? I'm multiplying the pink by what? Yeah. So you introduce an extra R. Yeah, still, yeah, still. Okay, so think about what a geometric series really is doing. Taking the first term, adding a bunch of terms when you're multiplying by R repeatedly, right? So the second term is A1R, third term is A1R squared, fourth term is A1R cubed, fifth term is A1R4, until you get to the last term, which is that. Now let's take a look at the pink. What if I multiply each side of the pink by R? So this gets multiplied by R, therefore this gets multiplied by R. So this is that become RA1. That this becomes A1R squared. This becomes A1R cubed, dot, dot, dot. This last term becomes what? A1R. Yeah, what if I multiply R to the n minus 1 times R? What's R to the n minus 1 times R?
R to the n.
Yeah, that's just yeah, if I multiply it by R, it becomes just that. Now, this is the part where it gets really fun.
What's the y?
Why? Great. Here's what's gonna happen. Just watch. What if I subtract these two equations from each other? Wouldn't those go away? Wouldn't those go away? Wouldn't all of these just go away? What are you stuck with?
Plus A1 RN.
Yeah. What can I factor out here? What can I factor on the right side?
Or shouldn't it be A1 minus A1 RN? Oh, plus.
Oh, you're right. Thank you, Sean. I know I can count on you to correct me there. Yes, correct. That should be minus because we're subtracting these two from each other, right? Thank you for seeing that. And then finally, when I isolate S sub n, what do I get? So it's kind of a creative way of doing the derivation. So it's not some wacky front just fell out of the sky. We understand logically what's happening with pink. Logically, this should happen to blue. We're looking at R. Logically, if I subtract now, was that obvious to subtract them? No, that wasn't obvious. That was a little. This is a little crafty here. But then I goes, oh yeah, I factor S sub n. Oh yeah, I factor A sub 1. Okay, now I get the formula. So that's how the formula comes about. By the way, for an infinite geometric series, actually, we'll talk about it in a moment. I don't want to do too much, but does that make sense? How I got that? Okay, I'll wait. Okay, do you see how I got the stuff in pink?
Yeah.
Okay, do you see how I got the stuff in blue? Multiply by R. I took whatever was pink, multiply each side by R, right? Okay, then I subtracted two equations from each other.
Why?
Why? Because I felt like it. Yeah, yeah. That's just the creativity part. But it helps you to come up with a formula that consolidates everything. I do that. It just happens to work. It's just magic. That's magic in math. I don't know.
Divide them.
You cross out S sub n's, but that would defeat the purpose because we wanted a form for S sub n, right? So, if I subtract them and factor S sub n, then I isolate S sub n and get that. That's like a formula. Now, if we talk about infinite, actually, I'll talk right now. If we have an infinite series, right? Infinite means it never ends. And what if R was a fraction between -1 and 1, non-inclusive. So how would I simplify this further? We talked about this last week, I think. It's A1 over 1 minus R. Right? If you think about it, if R is a tiny fraction, and you raise it to a large exponent, what happens to that fraction?
0.
It just goes away. We're stuck with A1 over 1 minus R. So that's how that formula also comes about too. So a lot of logic happening here. Let's take a look at examples 5A and B, and then we'll do the ones at the end, and then we'll be done for today. And stop this recording.